All right, for number 3, we have this function, h of x equals x squared minus 36 over x plus 6. And we're asked to determine whether or not this is continuous at x equals 6 and at x equals negative 6. And then if we determine that it's not continuous, what type of discontinuity do we have? So let's start with x equals 6. So what we want to know is this continuous at x equals 6? So we have a 3-part test for continuity. Step 1, we want to ask, does this function exist at x equals 6? So does h of 6 exist? Well, let's test it out. Let's plug in 6 and see if we get a real number for our solution. So 6 squared is 36, minus 36 is 0 on top. And on the bottom we get, if we plug in 6 for x, we get 6 plus 6, which is 12. 0 divided by 12 is 0. We can do that. That's a real number. And so that exists. So our first step, does this function exist at x equals 6? That's a yes. Yes, it exists. So now we get to go to part 2. Part 2, does the limit exist? So the limit as x approaches 6 of h of x. And we want to see if that exists. In other words, as we get closer and closer to 6 from both sides, is our function getting closer and closer to some number? And is it the same number coming from both sides? So let's check that. Let's plug in some values here. Let's start in the middle with h equals 6. We already know, because we plugged that in, we know that that equals 0. And then we'll test a couple more values on either side. So on this side, let's go with some numbers that are bigger. So 6.1, 6.01. And on this side, we'll try like 5.9 and 5.99. So we're getting closer and closer to 6 from both sides. And we're going to check to see if our function value is getting closer and closer to some number. So if we plug in 5.9 squared minus 36 divided by 5.9 plus 6, this gives us a negative 0.1. And then if we plug in 5.99, this is going to give us negative 0.01. And then let's test out this 6 squared minus 36, or 6.1 squared minus 36 over 6.1 plus 6 gives us a value of 0.1. And then if we plug in 6.01, we get 0.01. And you can test that out on the calculator. I've done it on the calculator already. And these are the values that I came up with. So, so as you can see, as x gets closer and closer, this should be x, not h. As x gets closer and closer to 6, then h is getting closer and closer to 0. So the limit does exist because it's getting closer and closer to the same number as we come in from both sides. And that limit is equal to 0. So we passed part 2 of our continuity test. And part 3 is just, if this limit exists, is it equal to the value of the function at x equals 6? And it is. It's 0 in both cases. So this is continuous. At x equals 6. All right, so that's the first half of our question. We were asked to tell whether this is continuous at x equals 6 and at x equals negative 6. So let's try negative 6. All right, step 1, does this function exist at x equals negative 6? So let's check h of negative 6. If we plug in negative 6 squared is 36, minus 36 is 0. So we still have 0 on the top. In the denominator, though, we get negative 6 plus 6, which is 0. So this is undefined. So does the function exist at x equals negative 6? No. So we can stop there. We don't need to do the rest of the test for continuity because we know it's not continuous right now. So this is not continuous. But what we do need to know is what type of discontinuity do we have here. So let's test. So I said we didn't need to do the second parts. And we don't in order to figure out whether or not it's continuous. But we do need to do this to answer the second question, which is what type of discontinuity do we have? So let's have x equals negative 6 here in the center. And it's undefined. We don't know what this limit is, but we know that right at negative 6 it can exist. So let's test some values that are a little bit smaller than negative 6 and a little bit bigger. So let's plug in negative 6.1, negative 6.01. Over here we'll have negative 5.9 and negative 5.99. And I did these on the calculator as well. And I got, for negative 5.99, I got negative 11.9. For negative 5.99, I got negative 11.99. And over here at negative 6.01, I got negative 12. That's negative 12.01. And at negative 6.1, I got negative 12.1. So here, notice that the limit does exist here. As we get closer and closer to negative 6, we're getting closer and closer to a single number on both the right and the left. We're getting closer and closer to negative 12. So we're going to say that the limit does exist, that the limit as x approaches negative 6 of this function h of x is equal to negative 12. So what this means for what type of discontinuity is happening here. Notice that as we get closer and closer to negative 6, everything's fine. We're getting closer and closer to the same number. It's just that right here, it doesn't exist. So what's happening with this function is we're going up, everything's fine. It doesn't exist at one point, and then it continues going up in the same way. So what we have here is just a hole, and that we call a removable discontinuity. So for x equals 6, the function's continuous. At x equals negative 6, the function's discontinuous, and it's a removable discontinuity.